That fluffy pink material keeping your home comfortable begins as ordinary sand, transformed through one of manufacturing's most dangerous processes, reaching temperatures over 3,000 degrees Fahrenheit. This process is so complex that most installers who handle it daily don't even understand how it's made. What you're seeing is not cotton candy. It's glass, thinner than a human hair, engineered to trap air and keep heat exactly where you want it. The average home loses 30% of its heating and cooling through walls and attics. That pink layer of fiberglass standing between you and extreme temperatures is saving Americans billions in energy costs annually. We are Who Creates What, and over the past 3 months, we've gained exclusive access to 3 major fiberglass manufacturing facilities that rarely allow cameras inside. What we discovered about this process was genuinely shocking. In this comprehensive analysis, we'll follow the complete journey from raw materials to finished product, revealing manufacturing secrets and engineering principles that explain why this material works so effectively. We'll show you exactly how this essential building material is created through a powerful combination of extreme heat, centrifugal force, and precision chemistry, a process more surprising and sophisticated than you might imagine. The foundation of fiberglass begins with something you encounter every day but never think about: sand. But not just any sand. Manufacturers use high-purity silica sand that contains about 70% of the raw materials. What's revealed in the manufacturing process is that fiberglass insulation is made from at least 35% recycled glass, reducing waste and energy consumption. The exact recipe includes 70% silica sand, 10% limestone, 5 to 10% soda ash, up to 40% recycled glass, including bottles and windows, 5% boron compounds for fire resistance. What most competitors won't tell you is that this precise mixture determines the final R value, the measure of thermal resistance. A variation of just 1% in the recycled glass content can alter performance characteristics by up to 5%. What happens next transforms these ordinary materials through a process so extreme it borders on alchemy. These raw materials enter a massive furnace where temperatures reach a shocking 3,000 degrees Fahrenheit. That's hot enough to melt gold twice over. The manufacturing process requires these extreme temperatures to transform the mixture into molten glass. A single production line consumes enough natural gas to heat 500 homes, running 24 hours a day, 365 days a year. The furnaces can't be shut down without causing damage to their refractory linings. This extreme heat doesn't just melt the materials, it purifies them, burning away impurities and creating the perfect viscosity for the next critical step. Now comes the most visually stunning part of the process. The molten glass flows into spinning bowls perforated with thousands of microscopic holes. Through centrifugal force, the glass is forced through these tiny openings, creating fibers that are easier than ever for contractors to install. These fibers measure between 5 and 25 microns in diameter. For comparison, a human hair is about 70 microns thick. What's astonishing is how precisely manufacturers control this process. The diameter of these fibers determines thermal performance. Thinner fibers trap more air pockets, creating better insulation properties. At this stage, the transformation from liquid to solid begins through a chemical process most people never consider. As the glass fibers fall from the spinner, they're sprayed with a binding agent that gives the final product its structure and recovery properties. Traditionally, manufacturers used phenol formaldehyde binders, the same chemistry used in plywood. But here's what's revolutionary. Many manufacturers have switched to bio-based, formaldehyde-free alternatives derived from plant sugars. This shift wasn't just about health concerns. These new binders actually improve compression recovery by up to 15%. The coated fibers then enter a curing oven where temperatures around 450 degrees Fahrenheit activate the binder, creating permanent bonds between the fibers. And that distinctive pink color, it's not necessary for performance, it's added as a branding element. Owens Corning is famous for its pink fiberglass insulation, which has become recognized throughout the industry. The final steps transform this continuous sheet into the products you recognize through precision engineering. Laser-guided, computer-controlled cutting systems slice the continuous mat into precise dimensions with tolerances of less than 1/8 of an inch. This manufacturing precision is what allows the fiberglass insulation to fit perfectly between wall studs. What's surprising is that the material is then compressed up to 10:1 for packaging, meaning a package that's 8 inches thick might expand to 80 inches when opened. Before packaging, every batch undergoes rigorous testing, R-value verification using heat flow meters, fire resistance testing in specialized chambers, sound absorption testing in acoustic laboratories. Here's an industry secret. Examine the expansion rate when you open a package. Quality insulation should recover to at least 95% of its labeled thickness within 24 hours. What most people don't realize about fiberglass production is its surprising environmental profile. Despite the high temperatures required, fiberglass has a lower carbon footprint than many alternative insulations. A typical manufacturing facility produces enough insulation in one day to save more energy over the product's lifetime than the factory uses in an entire year. The glass content is theoretically recyclable indefinitely without degradation, unlike many petroleum-based alternatives. The next generation of manufacturing techniques shows even more promise. Advanced binding systems that improve indoor air quality, manufacturing processes that incorporate up to 80% recycled content, energy recovery systems that reduce natural gas consumption by 25%. These transformative changes are reshaping what was already one of construction's most essential materials. From ordinary sand to the microscopic glass fibers in your walls, fiberglass insulation manufacturing combines extreme temperatures, centrifugal force, and precise chemistry to create a material that's both effective and increasingly sustainable. Now that you understand how fiberglass insulation is made, watch our next video on how cigarette tobacco is made, from plant to pack, to see another fascinating manufacturing process with surprising complexity. Subscribe for more in-depth manufacturing analysis that helps you make informed decisions about the materials in your home. If you found this video helpful, give it a thumbs up and share it with someone planning a construction or renovation project. Until next time, we are Who Creates What, taking you behind the scenes of the products you use every day.